All right, welcome. In this video, we're going to do a little bit of extra practice on the definition of the limit for AP Calculus. So I got to get my stylus here. All right, we'll get to it. So at what values of k, if any, does the limit of f of x as x approaches k fail to exist? Okay, so where is the limit non-existing? Okay, well, we know that really that's a picture of the limit existing. This is also a picture of a limit existing. Pretty much anything else is going to be the limit non-existing, okay? So that would be at x equals 3. Or k equals 3, pardon. K is the value of x where the limit doesn't exist. Okay? At what values of x, if any, does f of x not exist? Well, f of 3 exists. I can see it right there. Okay? And so like x equals 3 is not going to be a place where f fails to exist. F is going to fail to exist at x equals -1 and what I would assume is x equals -1/2. Okay. That's all they're asking about this one. Right, now here's one that's a little interesting. It says the graph of g is pictured below. What is the limit of g of x as x approaches -1? Well, I didn't look at this problem set before I started in on this, so this one might be a little tricky, right? So we know that it always goes back to the idea of the definition of the limit, right? From the left side, from the right side. So as we approach x equals -1, what's happening? G of x is approaching 2. Okay? So I'm going to just write that in. Pardon me. That's not good. Oh, wow. Having some tablet troubles here. Okay, let's get rid of that. Say that. Okay, I'm going to have to pause. All right, I'm back. So what I was trying to say was as x approaches -1 from both sides, g is approaching 2. So I feel like what's happening is we're interested in, and then I might say, okay, let's just bring in a new variable for discussion. As t approaches 2, g approaches, well, it depends on what side you're looking at. Okay, g approaches 2 different values. So let's think about this. Oh, I see. This one's very tricky. Okay. G is not only approaching 2 in that first line, right? If we look over here, just like right next to that open circle, as x is approaching -1 from above, G is approaching 2 from below. Ooh, this one's very tricky. I almost tricked myself on it. So let me clear out all this. So that was what's supposed to distract you, right? The 2 different things are happening to G as the input goes towards 2. What I'm going to say is G approaches 2 from the negative side. Okay. So let's think about, kind of a progression of x equals -1.1 to x equals -1.01 to x equals -1.001. Okay, that should be more than enough, right? As that's happening, x equals -1.1 corresponds to, let's say, 1.9. In fact, I know it does, because it's like on a slope of 1, it looks like. So g is equal to 1.99, and then g is going to be equal to 1.999. So we see that g is approaching 2 from below. Okay? Meanwhile, as we see x equals -0.9, x equals -0.99, or x equals -0.999, the same thing's going to happen. Maybe not exactly the same, because to the right of that point, we've got what looks like part of a parabola or something there. So it might not be exactly the same, but it's very similar behavior. Okay? And that, what I'm saying is that means that I need to be considering the limit as the input of g of x, right? We're thinking about g of x, but we said g approached 2 from the negative side. So this right here, I'm thinking about this approaching 2. So this is the same as the limit as t approaches 2 from below of g of t. And that's going to be equal to 5. And this is another really challenging question that I probably found out of a textbook somewhere. I thought I'd share that with you. It's the extra practice, right? So you tuned in, so here you go. All right, that's number 2. All right. Now, the next one is just, it's a piecewise defined function. What's the limit of f of x as x approaches 2 from the positive side? Okay, yeah. So positive side of 2 is someplace where x is bigger than 2, okay? So we're thinking x approaches 2 positive, though that's going to be where x is bigger than 2. So I'm going to use this piece of the piecewise function. See what the limit from the right is. So I'm just going to plug in directly, right? So I'm going to say when x is bigger than 2, it's going to be, okay, so 2 squared minus 4x, whoops, pardon me, plus 8. All right, so 4 minus 8 plus 8, that's equal to 4. Okay, so I'm going to say that the limit as x approaches 2 from the positive side of f of x is equal to 4. Had it been the limit as x approached 2 from the negative side, we'd have plugged into x squared minus 4x plus 4. And if they'd asked us what the limit as x approached 2 just in general was, we'd have probably said it wasn't going to exist because I got 2 different things from each side. Okay? I think I'm going to leave that where it is. All right, now this next one's going to give you a table, and it's going to ask you about the limit of 2g minus f. Okay, well, that part will be easy, right? We'll just use the properties that we know that this limit right here is going to equal 2 times the limit of g minus the limit of f, both as x approaches 3. Okay. So that'll be, the limit of g is 8, so that's 2 times 8 minus 2, pulling those numbers from the table. And so that would be 10 minus 2 is 8, or, no, that's not 10 minus 2. That's 16 minus 2, which is equal to 14. Okay? Now, the other part was it was asking me to give a sketch. We can do that. Need to cover that up a little bit. And I'm going to say near x equals 3. Okay, h and g. So I'm going to sketch y equals h of x in red. And, okay, so the limit of h of x does exist and it equals 2. But h of 3 is equal to 4. Okay, suppose that has a height of 2, right? We don't really know what's happening on either side of it, but we know that very nearby it's approaching y equals 2. And then the actual value of the function is up there, it's 4. Okay. And then g of 3 is equal to 8, and the limit of g of x is also 8, so I'm going to draw that. It's going to be up on top of the table. Maybe I know what I'll do. I'll clear out this discussion. We've moved past that. And I will draw nearby x equals 3. Okay, so the limit of g of x is equal to 8, and maybe I'll just editorialize a little bit and say, oh, maybe it's coming from above. It could be coming from below, or it could be constant, who knows? Okay, suppose that's at y equals 8. Okay, so the limit of g, okay, you thought I was going to go down, decided to go back up. The limit of g is 8, okay, that's the height. But g of 3 is also equal to 8, which means we're going to fill that circle in. And that's something that we're going to talk a lot more about, I believe, 2 lessons from now, when we talk about continuity and the definition of continuity and stuff like that. Okay, so that's what's going to happen. It's going to fill in, and it's all of a sudden going to be a continuous graph at x equals 3, and that's going to be very close to our definition for continuity is what you're seeing in that table there. We'll get to that with time. All right, now number 5, this one's a little tricky as well, but just like I told you in class, all of the actually difficult limit questions in AP Calculus, they always go back to the definition, right? The definition of the limit. The one-sided limits have to both exist and agree. Okay? So which of these is false? We're going to be able to solve this one pretty easy by process of elimination, but it's kind of hard to understand why the one that is false, right? So we're going to say, okay, the limit of f as x approaches 1 equals 0. Well, I mean, that's true. So I'm going to label that as true. Okay. Then the limit of g as x approaches 2, so that's right there. Yeah, that limit doesn't exist because from the left it's approaching 1, and from the right it's approaching negative 1. Okay. So I would say, let's get rid of that. Say this is also true. Okay. The limit of the product of f of x multiplied by g of x plus 1 as x approaches 1 doesn't exist. Not sure about that one. That's going to be the one that ends up being right. And then the other one, the limit as x approaches 1 of f of x plus 1. So that's really f as x as the input is going towards 2, and g as the input is going towards 1. So like, oh, okay, as x approaches 1, f of x plus 1, we're saying what's happening to f near x equals 2. And then over here, what's happening to g near x equals 1? It's a continuous function. The limit is what we expect it to be. There's no funny business going on here. So yeah, that's definitely true also. So it must be the case that C is false. But why is that false? Why does that limit must exist? It's like, I mean, I see that jump discontinuity at x equals 2 on g. What's going on here? So we're going to investigate the one-sided limits. So we're going to think about the limit as x approaches 1 from the negative side of the product of f of x and g of x plus 1. Okay. Well, what's happening to this is, okay, what's happening, let's trace along f as x approaches 1 from the negative side. Okay. It's approaching 0. Multiplied by what's happening with g of x plus 1. Okay, so we're kind of approaching g of 2, but 2 from the negative side. So we're approaching 1. So 0 times 1 right there. Okay, but then I'm going to consider the limit as x approaches 1 from the positive side of f of x multiplied by g of x plus 1. Okay, 0 times 1, we know that's 0. And that'll be important because over here, f is approaching, we're approaching x equals 1 from the positive side. So f still approaching 0. And maybe you can see now why this limit exists. But I'm going to finish it off. G, we're approaching x equals 1 from the positive side, so it's kind of like getting closer to g of 2 from a place bigger than 2. And that's going to be 0 times negative 1. But we know that 0 times negative 1 is also equal to 0. And since these limits both are equal to 0, we know that this limit right here, probably a poor choice of highlighter color, it's all right. We know that limit exists as well because its one-sided limits both exist and agree. So that's why this one must be false, and that's the answer. Okay? So that's all for this set of extra practice problems. Thanks for watching.